Chebyshev, sorry. Always want to give it a little extra. In any distribution, the percent of observations falling within k standard deviations of the mean is at least 100 times 1 minus 1 over k squared. So, k represents the number of standard deviations. So k is going to span, it's going to belong to the set from 1 to infinity, which really just means k belongs to the set where what? An interval notation. So, apologies, big yawn. So, you could go out infinite standard deviations from the mean. The problem is it starts becoming a little bit less meaningful the further you go away from the mean, right? The benefit of Chebyshev's inequality is it's not limited to just a normal distribution. All right, it's flexible enough to handle any kind of distribution. All right. So we'll take a look at it real quick using Desmos, just by typing in the inequality itself, or the expression that leads to the inequality. So 100 times 1 minus 1 divided by k as an element squared. Create a slider for k. Now this slider has a default setting, or any slider in Desmos has a default setting to go from negative 10 to 10, including all rational values in between. Right? I really only want integer values starting at 1. So I'll tap on the low bound, make it a 1. On the upper bound, I make it whatever I want, but I don't want to go too high because then it's too hard to slide back and forth. 4 minutes, so all good. So I'm going to put it at 1 to 5. I mean, you can put it at 1 to 500 if you want. The problem is, well, actually, let me show you what the problem would be. I'll put the step at 1, and I'll go from 1 to 500, because like I said, you can go out to infinity. So I do that, and now I want to land on a particular number, like let's say 121. It's really hard to do that now, because everything's so tightly packed. All right, so what I do with sliders is I just kind of default to something small, some small interval. In this case, 1 to 5 will get the job done. But if you want, you go like 1 to 10. And then if it goes beyond that interval, all right, so if you're outside the interval of 1 to 5, then just tap on the number and change it here. All right. What I noticed some people were running into when it comes to Desmos, like the day of a test should not be the first time you explore the ins and outs of Desmos. So take the time to get to know it a little bit more beforehand, because I did notice that some folks were looking to create a share link without having a Desmos account. All right, that sounds great in theory, except what you send me when you create a share link is the file that you clicked on, or the link that you clicked on initially. It would not send any of your changes. All right, so what you need to do is create an account and save your Desmos work, then create your share link. All right, these are the little growing pains when it comes to Desmos. You know, by the end of the year, you know, depending on college acceptance, depending on what colleges take AP exams, your level of motivation to, you know, prepare for said AP exam will vary from person to person. Some people want to strive for the 5. Just coined that myself. And other people will settle for. I have nothing that rhymes with settle that's in a negative connotation. Settle for. Yeah, like, but that sounds like a good thing.
Nettle.
Settle for like nettle.
Yeah.
Yeah.
That's it. That's the one.
Yeah. Yeah, if you've ever walked through nettle, it's not comfortable. So, anyway, the point is, it varies. So, you'll walk out of this class having mastered some form of technology, whether it's Desmos or the TI calculator. All right? So, it's just a question of which one you're going for. All right, but again, the day of the test should not be the first time that you start exploring these things. All right, if your goal is to use the technology to solve a problem, then you're on the hook for the knowledge that leads to that solution. All right, so just keep that in mind when I'm presenting stuff like this to you. All right, so what we have here is Chebyshev's inequality plugged into Desmos with k-values spanning from 1 to 5. So for the k-value of 1, we get a result of 0. At least 0% of observations will fall within one standard deviation of the mean. All right, well, if there's a data set containing 100 observations, this is saying at least none of them will fall in that interval. Okay, yeah, well, that's probably going to be true, I would imagine, because at least none of them means none or more, all the way up to infinity. So it could have 0%, 1%, or all the way up to infinity percent. However, if we're dealing with finite math, we would cap it off at 100%. All right. If we go to 2, and we are dealing with finite math, 75% of the data will fall within 2 standard deviations of the mean. 88.8 repeated percent will fall within 3 standard deviations of the mean. Now, if you're comparing this to the empirical rule is a limitation on Chebyshev's inequality. If you think of 1 standard deviation by the empirical rule, about 68% of the data falls within 1 standard deviation of the mean. Well, 68 is at least 0%, so it's true. It satisfies the criteria. 2 standard deviations by the empirical rule would contain about 95% of the data. That's at least 75% of the data. Again, 75% of the data at least would be 75% or more. That would capture 95% of the data. All right, and then the 3 standard deviations by the empirical rule would be about 99.7% of the data. Chebyshev's inequality is saying at least 88.8% repeated of the data would be captured by 3 standard deviations of the mean. 99.7 is at least 88.8 repeated percent of the data. All right, but this goes beyond that. Allows you to go 4 standard deviations, 93.75, and even up to 5%, 5 standard deviations, so 96%. All right, if you want to go further, you can. It's really up to you. Recommendation: if you're going to go further, you might consider making a function out of it. It won't be a discrete model. It'll be a continuous function. It'll have, all the good stuff that comes along with functions, like asymptotes and things of that nature. But with a function, you're not limited to just a trial and error approach. All right. However, you are multiplying by 100, so that'll scale it up pretty substantially. If you drop that 100, then you could scale it down so that it's a little bit more convenient for the graph. All right. Now, this hasn't really come up too much in this class in terms of, creating graphs just in general. If you want to truncate a graph on Desmos like a piecewise function, you just state the domain in squiggly brackets after you type in the equation. All right. So for Chebyshev's inequality, they're saying at least 1. All right. So in terms of the number of standard deviations away from the mean. All right. So what I would do is after the squiggly bracket, open squiggly bracket. Then after the squiggly bracket, type in x greater than or equal to 1, and it'll give me the relevant part of Chebyshev's inequality, so I could see what's actually happening here. All right. So if I play around with my domain a little bit, my range, my domain, I could pretty much go out wherever I want, but the range is going to max out at 100% of the data. So I'll make my y a 1, so I get a better view. and I can see that there's a horizontal asymptote here, and it's pretty clear that as I increase my k value, which is now represented by an x, that the function is approaching 1, doesn't appear to ever get there. We're looking at a horizontal asymptote, all right, because this is a rational function. Good old pre-calc in action. Yeah, so this type of modeling is pretty useful in this class, but it doesn't look very pretty, all right? So it is what it is, though. So I'll dress this up, get it up on Schoology for you so you have it. The Chebyshev's inequality, Desmos I'll call it, or something along those lines. And I'll throw a couple of notes in there so that you can refer to it. But as far as the lesson's concerned, that's it. So you have the remainder of class